Hi, I'm Mark Levy, the Sourdough Simpleton, and this video looks at what do sourdough ratios mean and why do I care? You know, perusing sourdough websites and Facebook pages shows that many of them try their very best to explain sourdough ratios. These are the ratios that are followed when growing a starter for use in a recipe. You'll see 1 to 1 to 1. 1 to 2 to 2, 1 to 3 to 3, maybe even 2 to 1 to 1, all kinds of numbers. But the real question is, what does all that mean and how does it apply to you? So let's go through a couple of things and try and make some sense out of all of this. Simply put, a sourdough ratio is the ratio of 3 ingredients used when you set up a starter to rise. Those 3 ingredients are, number 1, the amount of existing starter that you're going to use to seed the mixture. Number 2, the amount of flour that you're going to add. And number 3, the amount of water that you're going to use. The ratio describes the relationship of these 3 ingredients with regards to their weight, not their volume, and that's important. Flour weighs about half as much as water, and a starter's volume depends on how well risen it is. So using a volume measurement is fraught with peril. Please don't do it. One of the most common ratios you're going to see is 1 to 1 to 1, which specifies equal weights of starter, flour, and water. The weight itself is not specified. It might be 50 grams, or 250 grams, or even a pound. As long as the same weight of each component is used, it's a 1 to 1 to 1 ratio. With all these mixtures, the amount of each component used is based on what your final need for starter will be. So, let's say you're making a recipe. Calls for 240 grams of starter. So you might use 100 grams of your existing starter, 100 grams of flour, and 100 grams of water. You'll end up with 300 grams of active starter, from which you will take the 240 that you want for your recipe and set aside 60 grams that's left over for the next time that you'll need starter. Let's call that the discard, because you're going to discard it, okay? Now, there are some variables in this whole scheme that can affect the process. First of all, the starter that you're going to use to seed the mixture may be an active starter that you just used for something, or it may be unfed, inactive starter, which we can call discard. It's been sitting around for a week, a month, or longer. If you use unfed starter, the time needed to double in volume, which is what your goal is, will be longer. The ratio itself is a factor. If you use less initial starter in relation to the flour and water, it'll take longer to grow as well. So, a ratio of 1 to 2 to 2, with twice the weight of flour and water as starter, will take longer to reach doubling of volume than a ratio of 1 to 1 to 1. Temperature also plays a role. You can check out my video on the effects of temperature on rise times, with a warmer temperature helping the starter to rise faster. With all of these variables, it's difficult to answer the most often asked question I see, which is, how long will it take my starter to rise? I mean, it depends, you know? So in order to answer that question, at least somewhat, let's have a look at a couple of examples to illustrate these issues. All of these batches were done at a room temperature of about 68 degrees Fahrenheit, 20 degrees Celsius, which is a tad on the cooler side, and that will prolong the time necessary to rise and accentuate some of the differences. They all start with about 150 grams of total mixture as well, so they're all roughly comparable. First off, here's a 1 to 1 to 1 mixture. That's 50 grams of starter, 50 grams of flour, and 50 grams of water, using a 2-week-old, unfed, hoochified starter as the base. Take a look. So here's the setup you're going to be looking at. First of all, the starter is rising in a cylindrical starter jar, which has measurements on it. You can see this begins at about 175 milliliters, because the jar measures in volume, but that was the 150 grams of starter, 1 to 1 to 1, 50 of starter, 50 of flour, and 50 of water that we begin with. And they're all going to start at about the same level. On your left, you see a thermometer. Also happens to have a hygrometer on it for the sake of argument. But it's going to show that the room temperature is about 68 degrees. It's going to bobble a bit to 70, but it's about 68 degrees for the entire time. And on the right, you see a clock. Now, this clock looks like it's running very rapidly. That's because this is time-lapse. And we're actually now at almost, coming up on 5 hours into the process. And you'll notice that as of right now, nothing has happened to this starter. Remember, this is old starter, which has been sitting around for a while, and it takes a while for it to get active. In fact, you may see a little creep right about now, but it's about 8 hours into this process when this starter really starts to rise. So we're sitting at 6 and coming up on 7 hours now, and then you'll begin to see it rise. Let's have a look. Exciting, isn't it? And now at about 8 hours, it begins to come up. And will continue to rise very slowly. We're at 9 hours now. Coming up on 10 hours into the process. And we're going for a doubling, which will be roughly a 300 milliliter volume. We're at 11 hours and still rising. So at 12 hours, the clock's going to scroll back, so we have to remember where we are. We just passed 12 hours. And this is 13 hours. And coming up on. And at 14 hours, we've just about made our 300. We'll let it go a little bit longer and see how it looks. This will be 15 hours. And that's about where she sits. So now, here is that same 1-to-1 mixture, but using a fairly fresh, day-old starter to seed the mixture. So here's the same setup, but now using a fresh starter. And you'll notice that almost within an hour, you're seeing movement of that starter to begin to rise. Much quicker than the hours and hours that the older starter took. And in fact, we're only at about 2 hours in now, and you're already seeing it up over 200 milliliters. With a peak goal of 300, we're going to get there very soon, in about 3.5 hours to get to the peak. So this is one which you could bake early in the day and have ready to bake in a couple of hours. So it's obvious that using a fresher starter yields a faster rise. Turning to a ratio of 1 to 2, we can have a look at the same setup. Now this mixture uses 30 grams of starter, 60 grams of flour, and 60 grams of water, yielding the same 150 grams of mixture. You might use a 1 to 2 ratio, for example, if you need a lot of starter and only have a limited amount to begin with. So 100 grams of old starter mixed 1 to 2 would produce 500 grams of active starter. And of course, you could use that to seed even bigger quantity if you needed it. So these ratios do have a practical use. So first off, let's have a look at a 1 to 2 mixture using a 2-week-old unfed starter and see how that comes out. So here's the same old setup. The starter jar rising with 1 to 2 ratio of starter mixture. That's 30 grams of starter and 60 of flour and 60 of water. Now I've sped this up a little bit. This actually is running a little bit faster for time lapse than the other one because it does take a while. You'll notice that we're at coming up on 4 hours now, and this hasn't budged, and it's going to take a little bit more time for this to go. Interestingly, the room is a little bit warmer here. It's 70 degrees from 68, so you'd think it might even be faster. But using the old starter and the smaller amount of starter seating, so that it's the different ratio with 1 to 2 to 2, it just takes a lot longer for this to get started. This is one that you would use typically overnight to have a starter ready for you in the morning. You can see now that we're at about 8 hours, and it's rised a little bit, come up a little bit, and but still not anywhere near where you want it to be to double to 300. We're at getting close to 200 milliliters, and it's coming up on it's 11 hours now, and it'll be 12 hours pretty soon. I'm willing to entertain guesses from you all as to how long it's going to take, but you'll see in just a few seconds, because thanks to time-lapse photography, we can show you a very long time in only a couple of minutes. But you can see now it's begun to come up slowly, very slowly, and it'll hit that 300 mark at about, you ready for this? About 16 hours into the total time when it gets to really where it doubled. So unlike the 1 to 1 to 1 ratio, this even takes longer to get up there, and it certainly has a use if you have to make a lot of starter, but I usually use 1 to 1 to 1 to raise my dough, because I just don't have that kind of time to sit around and wait. But overnight's always good too. So we're getting up there. We've just crossing the 300 mark, and that's at 8 hours. So that's where we sit. Now we'll use that same 1 to 2 to 2 ratio, but we'll use that day-old newer starter and see how that looks. So here we are back with the same familiar setup. The thermometer sitting at 68 degrees Fahrenheit. The starter jar starting out with about 150 milliliters of the 1 to 2 to 2 ratio, this time using the fresher or day-old starter, and the time clock showing us how quickly it's going. Now you may recall that the 1 to 1 to 1 ratio with the newer starter took about 3.5 hours to peak out. This is obviously going a little bit slower than that, but it's going quicker than the old starter did, that's for sure. At about 3 hours, we're 200 milliliters up with only 100 milliliters to go in volume. So it looks like we're going to be a lot quicker, certainly one that you could use on the same day if you liked. And that's the whole point. If you can use a fresher starter to start out with, then you're going to get a much more rapid rise. So in fact, we're going to top out at about 6 hours for this starter to get to the 300 milliliter mark, about twice as long as the 1 to 1 to 1 ratio took. So we can learn a few things from these demonstrations. The more starter you begin with in relation to the flour and water, the more rapidly the mixture will rise. And the fresher the starter is to begin with, the more rapidly the mixture will rise. And if you check the other video, the higher the temperature is, within limits of course, the more rapidly the mixture will rise. While a shorter rise time may be desired if you're starting a bake and plan to do it in a few hours, a longer rise time can be useful if you start the mixture, say, in the evening, and you have it ready for a morning bake. By using the factors carefully, you can get a good handle on knowing just when that starter will be ready for use. Overall, this is a very useful thing to understand and to be able to use in your baking. And I hope I've answered all the questions, every single question you had about sourdough starter ratios and why you should care about them. But I look forward to your comments and thoughts on the things that I didn't cover. Check in on the Sourdough Simpleton channel here on YouTube or on the Facebook page, Sourdough Simpleton, and all of my videos to date are cataloged on the website, sourdoughsimpleton.com. Please do subscribe to the YouTube channel, join the Facebook page, and check in on the website. And let us hear from you with your comments, questions, problems, and successes. For now, until next time, I'm Mark Levy, and this is the Sourdough Simpleton.